In this video, we will learn how to group our Simulink model into subsystems. We will also learn the naming conventions of these subsystems so they are properly recognized by RT Lab. These steps are mandatory to be able to run a model in real time. Let's explore how we can break our Simulink model into separate subsystems. RT Lab subsystems have two uses. The first is to distinguish computation elements from the GUI elements. The second is to assign separate computation processes to separate CPU cores. As a rule, the top level of a Simulink model can only display subsystems. It cannot include any other block. In some cases, we could have a computation subsystem without a GUI subsystem at the top level. For instance, when doing overnight automated testing where the results are being stored in a MAT file, a GUI is not mandatory. Let's look at an example using this model. We can see that the elements in the center that belong to the computation block are all the mathematical manipulations in the model, or the calculations. Thus, they are grouped together in a computing subsystem. The GUI blocks on the left and the right are for user input and feedback. They will go together in another subsystem. Here is the final model separated into different subsystems. Now, let's look at the hardware to identify where those subsystems will be running. Here is a typical Opal RT simulator setup. On the left, we have our target, and on the right, we have a host PC. As we can see, our computation subsystem will be assigned to a core of the simulator. The GUI subsystem will in turn be assigned to the host PC. However, what if the model we are developing is so big that we need to use more resources of the simulator than just the one core? Let's see what happens then. In this diagram, a second computation subsystem called SS Computation 2 has been created. This subsystem will run on the second core of the simulator. Notice that each of our subsystem blocks carries a particular prefix. This is used by RT Lab to distinguish the purpose of each subsystem. On the right is the GUI. It carries the prefix SC_. At maximum, there can only be one GUI subsystem in a model. For computation subsystems, we use the prefix SM_ for the master subsystem and SS_ for slave subsystems. Any name can be used after the underscore as long as it does not contain spaces, which are prohibited. This table shows all the possible combinations our top-level model can have. For any RT Lab model, there must be exactly one SM_ subsystem. The GUI subsystem is optional, but there can be one at maximum. Recall that this subsystem will not run on the simulator, but rather on the Windows computer. Last, we can have as many subsequent computing subsystems as the simulator allows. The more SS subsystems there are, the bigger the computation power. With this knowledge about dividing a Simulink model into subsystems to make it real-time compatible, we can move on to the next video, which will cover how these subsystems communicate with each other.